In this podcast, we're going to be looking at some of the work solutions for the binomial distribution problems in assignment 2. First off is Musti with question 1A.
Alright, first I read the question and determined what all the different parameters were. And then I saw and looked at it and saw that if it was a PDF or a CDF, depending on if it was one trial or one or more, and it was a PDF. So then I entered the different parameters into the CAS calculator, which was under probability, binomial distributions, and put in the number of trials equal to 20, because it was exactly one sale. I put in X equal to 1, and the probability was equal to 0.15 from the question, and then just pressed enter and gave me the solution.
What was the solution? Solution was 0.1368, yeah?
Yep.
So we'll just write that in there. Cool. Will?
Okay, well, question part 1B, the probability that at least one sale in the next 20 calls. Well, it was at least one, so I knew there was two bounds, the upper bound which was 20 and the lower bound which was 1. So that means it was a binomial CDF. So I put that in the calculator as n is the number of trials, which is 20. Probability which we were given is 0.15. The upper bound, which is 20, the lower bound is 1, and the answer we got was 0.96124.
Okay. Mel, question. We'll go straight to 1D. There you go.
Alright, so this question was conditional probability, and conditional probability says that the probability of A given B is equal to the probability of A and B divided by the probability of B. And because in this case A is a subset of B, because if we were to look at the Venn diagram, it would be at least one, and in there would be two sales. So we know that the probability of A and B is equal to the probability of at least one sale. So I found out the probability of two sales by using binomial PDF, and the value n is 20, the probability is 15, and x is 2. And for greater than one sale, I found using binomial CDF, n20, probability of 0.15, lower bound of 1 and upper bound of 20. And then I divided the two and got 0.2386.
Excellent. Okay, next up is Will again. So this is question 2 we're on to. Let's move that across.
Question 2, part A, with the retailers' tests of some mobile phones before putting them on sale. Part A was the probability that the sample would have one or more defective batches with a 3% chance that the whole batch is defective. So it was a binomial CDF again because it's got a upper and lower bound. I used n was 5 because it's the number of trials. The probability was 3%, so 0.03. The lower bound was 1, the upper bound was 5, so the answer I got was 0.141266.
Cool. Back to Mel for part 2 of that one.
This was just a straightforward binomial PDF using the number as 5. The probability is 0.08 because that's 8%, and x is 0, and the answer I got was 0.6591.
Can you just write down an equation how you, if you want to explain mathematically why 8% is 0.08, can you just write down what you do in your calculator? What are you doing?
I don't know how to explain it.
What are you doing when you convert a percentage to a decimal?
You just divide it by 100.
That's right. So just write it down, 8 divided by... Cool. All right, moving on. Eliza.
The
probability of winning a prize with a lucky ticket in a game of chance is 0.05. If a person buys 20 lucky tickets, finding the probability of winning once. The number of chances we're taking is 20, and the winning we want is 1. The probability of us getting it is 0.05 and not getting is 0.95. We can use a binomial PDF to get the answer. And if we want to do it by hand, we use the binomial distribution equation, and that's done there.
Okay,
and
so
we get the answer.
what does n actually equal?
20.
And it's actually the number of trials, yeah?
Yeah, the number of
All right,
trials.
cool. Thank you. Wow.
Alright, so the question is asking the probability at winning at least one. So we know it's a CDF because it could be one or more. It's more than one. So we know that the number of trials is 20 and the probability is 0.05. So the lower bound, we use CDF, binomial CDF, and we put in n as 20, p as 0.05, the lower bound as 1 and the upper bound as 20. And the answer we get is 0.6415.
Okay, so when we say winning at least once, that really includes what?
1.
What else? At least once is winning once,
Or more.
twice,
3
3,
times 4,
up to
5,
20.
up to 20.
and that's why we use a CDF, because it's cumulative. All right, Nash, last one.
Alright, so this question's asking for the sample size, the number of trials, and it's given that the probability of winning at least once, which is more than one, equal to or more than 1, is 0.9. And so you take away from, say you take 1, wait no, you take that away from 1, which is 0.1, and then that's the same as probability of 0. And so you write it out, write the equation out, and you get that. So, and then n of 0 is just 1, and whatever's powered to 0 is just 1, so you just work that out, right? And you just put the log of that, because the log of two numbers it cancels out, so let's just become n equals log of 0.95, 0.01, and you put that in your CAS and you get 44.8, and you just round it off to the nearest numbers.
Well, we can't have 44. 44 trials won't get us there, but 45 will.
Yeah.
We could also have done, just put this into the CAS and go and solve that
Yeah.
comma
Just did it the
n.
long way.
Yeah, you did it a long way, but it's all right. Now, from this step to this step,
Yeah.
how do we do that? Why do we write it as x less than 1?
Because it's looking for that is the probability of 1 and whatever's more than 1.
Yeah.
So whatever's less than 1 is just 0. So that's not.
Yeah, because there's only one whole number less than
Yeah.
1, and that's 0. All right, cool. Thank you very much.